The previous video, we have learned the first exception to the octet rule, which is the incomplete octet. In this video, we're going to learn about the odd electron molecules. Some molecules contain an odd number of electrons. Among them are nitric oxide and nitrogen dioxide. Let us draw the Lewis structure for nitric oxide. First, we have to determine the valence electron for the nitric oxide. Nitrogen has 5 valence electrons, and oxygen has 6 valence electrons for a total of 11 valence electrons. Let us now draw the skeletal structure for nitric oxide. The skeletal structure has one single bond, so there are 2 electrons. We need to add 9 more electrons in the skeletal structure. We're going to add the electrons first in the oxygen atom because it is a more electronegative atom than nitrogen. So we're going to add 3 lone pairs and a lone pair and a single electron for the nitrogen atom. So we have now 8 electrons for oxygen and 5 electrons for nitrogen. Another Lewis structure for the nitric oxide is this. In this structure, oxygen has 8 electrons and nitrogen has 7 electrons. So which of the two is a more plausible structure for nitric oxide? Let us determine first their formal charges. So the formal charge for the nitrogen atom here is determined by subtracting its valence electron and the assigned electron, which is 4. So we'll have a positive 1 formal charge for the nitrogen atom. For the oxygen atom, it has 6 valence electrons minus 7 assigned electrons. That will give us a negative 1 formal charge for oxygen atom. So again, we have positive formal charge for nitrogen and the negative formal charge for oxygen. On the other Lewis structure, we have 5 valence electron for nitrogen and 5 assigned electrons. So we have a 0 formal charge for oxygen, nitrogen rather. For the oxygen atom, we have 6 valence electrons minus 6 assigned electrons. So we have 0 formal charge for the oxygen atom. Between the two, this second Lewis structure is more plausible than the first Lewis structure because it has a 0 formal charge for both atoms. Let us now write or draw the Lewis structure for nitrogen dioxide. Nitrogen has 5 valence electrons and oxygen has 6 valence electrons. Multiply it by 2. So we have a total of 17 valence electrons that will be distributed to the structure of nitrogen dioxide. Nitrogen is the central atom surrounded by 2 oxygen atoms. So this is the skeletal structure for the nitrogen dioxide. Since we have 2 single bonds in the structure, we already have 4 electrons. And we need to distribute 13 more electrons in our structure. Starting from the oxygen atom, we're going to put 6 electrons or 3 lone pairs and another 3 lone pairs for the other oxygen atom. Now the remaining electron will be placed in the central atom. Another possible structure for the nitrogen or the nitrogen dioxide molecule is this. Now, we are going to choose which of the two lowest structure of nitrogen dioxide is a more plausible structure by comparing their formal charges. So the formal charge for this oxygen atom is computed from its valence electron minus its assigned electron, which is 7. So we have a -1 charge or formal charge for oxygen atom. On this oxygen atom, we also have a negative formal charge. For this nitrogen atom, we have 5, 5 as its valence electron, and the number of assigned atoms is 3. So the total or the difference is positive 2. So this nitrogen atom has a formal charge of positive 2. Take note that if we're going to add these formal charges, it will be equivalent to 0 because this molecule is electrically neutral. On the other Lewis structure, we have 6 minus 6 assigned electrons, which is 0 for oxygen atom. We have 6 minus 7 assigned electrons. So we have a -1 charge for this oxygen atom. Sorry. And for this nitrogen atom, we have 5 minus 4 assigned atoms. Again, 4 assigned electrons. So we now have a +1 formal charge for a nitrogen atom. So if we're going to choose between the two Lewis structure, this is a more plausible structure of nitrogen dioxide because it has less formal charges compared to the structure or the formal charges of this structure of nitrogen dioxide. In the next video, we're going to talk about the expanded octet.